Okay, gentlemen, let's talk simulcasting. So, what is simulcasting? You have a bunch of repeaters, right? You've got repeater, let's say you've got repeater A right here. You've got repeater B. You've got repeater C. And you've got repeater D. Repeater A is where the controller is located. The controller being what all of these sites connect to, and it's what controls the timing and makes sure that all of these are always transmitting the same thing at the exact same time. Obviously, that's always going to be on the same frequency. Let's say that is, how are we going to set up our repeater? Let's use CAS 700. So 462.700 slash 467. I can't write, but you get the idea. And our PL for this system is 141.3. So the way that we have this set up is we have 4 machines, right? And each of those machines has an external controller attached to it. This is an unpopulated PCB, but this is your controller, right? That's your voter. That's your voter board, your simulcast control board, your RTCM, your whatever the heck you want to call it. So you've got one of those at each one of these repeaters, right? And those are your external controllers. That's how you simulcast. So the whole idea is that all of these controllers are linked to the primary controller and they all work. So they're all transmitting the same thing at exactly the same time. You just have one big repeater. But what happens whenever you lose your data link? Because let's say this is this link is provided by a 5 gigahertz radio, a DSL internet connection, a cellular modem, whatever the case may be. There is an IP data link between these two, and these two. What happens if that gets severed? Well, now you just have 3 repeaters that are all 4. You've got 4 repeaters that are probably all relatively close to each other, and they're all programmed for the same frequency and same PL tone. So let's say that your data links are broken because the internet went down or a lightning storm or something, whatever, and you've got a guy over here in a truck that wants to use the repeater. Well, he's going to start sending out signals to the repeater on this frequency and this PL tone. Let's say he doesn't know that the thing's down or whatever. Well, you've got signal going here and here and here. So he's keying up A, B, and C all at the same time because that's how they're programmed. They're programmed for that frequency and that PL tone. Problem is because the simulcasts the controllers aren't linked, the timing isn't right. So they're not actually simulcasting, they're just 3 repeaters operating at the same time, and all you're going to hear in the air is and it's not going to work. Sound effects are free, you're welcome. That will not work. And now your repeater system is pretty much completely useless unless you're like way over here on top of C and you're so close to it that, yeah, whatever. You've got a whole bunch of repeaters that are all stuck on the same frequency and PL tone and they're just causing interference with each other. The system is unusable in this state. That is a problem. It will not be usable until you get those data links back up. How do you fix that? Okay, we drew this out again without all the scribbles all over it. So let's say that this data link right here is lost. It gets broken for whatever reason. What you want to happen is for this machine to operate continuously as local only with a different tone than usual. You want all these to have separate failover or backup tones. So let's say this one is 67.0 is its backup tone, right? So whenever it disconnects, it automatically switches to use that tone instead. And then whenever it reconnects, it switches back to 141.3. That would allow you to continue using this repeater without keying up all the other ones. thereby letting you continue to use it even though it's disconnected from the rest of the system. All of these would have their own site-specific backup tone. Let's say that one's 67.0. This one's, I don't know, 88.5. 123.0. I'm just making these up. Obviously, it doesn't really matter. You could choose whatever the heck you wanted. And 131.8. That's valid, right? So these all have their own backup tones so that in the event that the data connections are severed, they automatically fail over to those backup tones until they reconnect, letting you continue to use the system if necessary in standalone mode. Okay, the whole point of that is so that you don't have to change this frequency. Obviously, you could program it so that it changes frequency too, but duplexer tuning, antenna, SWR, stuff like that, it's better just to change the PL tone, not the frequency, in my opinion. That's simpler. But anyways, how do we do this? How do we tell the repeater to automatically change PL tones or change to a different memory slot, I guess, whenever it disconnects from the host? Okay, I can already hear people asking, why are you about to try to do this on the repeater instead of just doing it on the controller itself? You can go in that controller's settings and go into the offline mode parameters, and you can tell it to output a different PL tone whenever it's operating in standalone mode or when it's disconnected. Yes, that is true. What you cannot do is you can't change the decoded PL tone. You can't change which tone is required to open the system on that controller, because that controller is not actually doing any decoding. The repeater itself is doing the decoding and then just passing a logic level signal to the controller to tell it if the correct tone has been decoded or not. So if you want to be able to key up an individual repeater in offline mode with a separate PL tone from the other sites, then you have to do this at the repeater and not at the voter control board. So from here on out, keep that in mind. This is why we are trying to get the repeater to change its settings whenever an offline mode is detected. Well, conveniently, if you look at this voter board right here, one of these LEDs, which is, I think it's this one, right? This LED is the connection status LED. So the firmware on this board, whenever you're finished building it and you get it loaded up and everything, the firmware on this board will actually turn that LED on whenever the connection is established to the host. The LED will turn off if the connection is lost. That is extremely handy for us. The way that LED is controlled is that power is always applied to the positive side of the LED, and then on the negative side of the LED, it runs to a GPIO pin on this chip right here. So this chip, actually, there's always power going to the LED. And then the chip, whenever the connection is established, it just grounds the ground side of that. So whichever pin it is, and I can't remember off the top of my head, whichever pin it is on here, the pin will be grounded when there is a connection. Remember that. Basically, it's an active low, I guess you could call it. It's a grounded when connected. Grounded when connected. That is extremely important for us. Now, in my case, I am talking about a TKR-840, and this probably applies to a lot of other repeaters. Basically, there is a remote I/O jack on the back of the repeater. Pins 1 through 12 are on it. And if you look, here is your channel select reference. So what you can do is you can select channel 1, 2, 3, 4, 5, blah, 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 just by changing whether or not these pins are grounded. So Kenwood did a bad job of not making this super confusing, but basically a 1 means not grounded and a 0 means it is grounded. So if you have this feature enabled, then if nothing is connected to any of these pins, then it will be in channel 1. If you ground pin number 6 right here, then it will switch to channel 2. And remembering that the LED on this is controlled by a grounding circuit pretty much, what we can do is we can take pin 6 and we can tie that into the same GPIO pin that controls the connection status LED. And what that will do is it will select channel 2 anytime that the connection status is on, and it will select channel 1 or revert to channel 1 anytime the connection status is off. So what does that look like in programming? Let's see here. What that looks like is we have channel slot 2, which is our connection status on channel, set to the simulcast system programming PL tone, however you want to word it. And then channel slot 1, which will be the revert if the connection is broken, goes back to whatever you want your failover PL tone to be, which is 67.0. And the way that you set that up is you go into optional features on the TKR-840 and go to aux input output and just set the first 5 ports, the input output ports, just set all those to channel select. And then right now I don't have anything else because I haven't actually finished programming the system yet. But just to show that it does work, what we have here is just a wire jammed into that pin. Uh-oh, it just fell out. Stand by, I gotta plug it back in. Okay. So we've just got a wire jammed into that pin 6 on the back of that thing. And now, anytime we ground this wire, it will change automatically to channel 2. See that? And that works perfectly for our case. So let's go over to the computer screen and look at some schematic stuff real quick. So here I'm actually modifying K3MK's thick client module, which is, at the time of making this, the most modernized version of Jim Dixon's original voter board design. So if we come down here to the radio connection, which if you look at the PCB layout, that's right here. That's the DB9 connector that the repeater will actually be connected to. What I've done is I've taken a spare pin that was tied directly to ground, pin 6 in this case. I have taken pin 6 on that DB9, disconnected it from ground, and I have instead connected it to the same leg that is controlling the host LED, which we talked about. This leg right here will ground whenever that connection is steady. So this pin 6 is your grounded when connected pin. So all you have to do is take pin 6 out of the back of the remote I/O jack of the 840 repeater and just wire that in with your DB9 connector for your control board interface. And once you've done that, you now have an automatic channel steering based on connection status. And I do have a video of this actually working with everything connected together. This video was taken a while ago using a Vertex standard repeater. Same exact concept, just a little bit different implementation. This was a while ago before I had done this PCB modification and stuff. So what I ended up having to do was, route a wire outside of the connector and do a bunch of funky stuff. But this video I'm about to show is it's the same concept, just showing it visually. Alright, I'm going to try to make a quick demo video showcasing my new failover implementation on the CAS 700 system. So what I've got right here is the Benton machine and its control board on the desk at my house. I had to bring it here to tune it and modify it to do this. So typically the way that this works in normal operation is the repeater's connected to the simulcast control board, and this control board connects through network back to the master control server here at my house. And that allows all of them to synchronize together. That server is what controls the entire thing. Without a connection to that server, they're basically just repeaters that are all on the same frequency, and they fight with each other the same way it would happen if anybody on multiple radios tried to start talking at the same time. So without the server, it doesn't work. They're unusable. So let's say that all three of them, all three locations lose internet, and you're in the middle of town and you're within range of all three of them because you got a really good radio set up on your vehicle. So you try to key up the radio, but they're disconnected from the server, so all three of them just start going haywire, fighting with each other. You're keying up three repeaters at the same time. Nobody can hear what you're saying. It's all garbled. There's too much interference. So ideally, what would happen is whenever it goes into failover mode, when it disconnects from the server, that is, for whatever reason, it would fail over to a different setting than the other repeaters. That way you could program the failover mode for Benton into your radio as a separate channel, and you could use it independently in the case that it is offline. That would allow the three repeaters to remain usable as standalone repeaters if they ever disconnect. So that's exactly what we've got here. Notice right now, this is actually the status indicator right there. That LED is on. We are plugged into the network. Everything's working as intended. It is connected to the CAS700 control system. It is currently on channel 2. If you look at my programming software for the repeater, you will see that in channel slot 2, I have the normal CAS700 settings, which is the 141.3 PL or CTCSS tone. That is what you would normally use to access it. Now notice channel 1 actually has a 77.0. So, in the event that the connection is lost, this machine will actually revert to channel 1 automatically. So I'll just demonstrate that by unplugging this network cable, and as soon as I do that, you will see that it switches over to channel 1. So we'll just use it normally real quick. I'll plug that network cable back in, it'll reconnect, and once it reconnects, which takes a few seconds, it'll go back over to channel 2. We've got our radio over here on CAS700, just the normal settings. Wait for her to fully boot and connect. There we go. On channel 2, normal CAS700 settings, WRKF394. 94. There we go. That's how we would expect it to act. Now, let's simulate a lost network connection. We've now failed over to memory slot 1, which, as we said, is a 77.0 tone now. So now you can key up Benton just by itself without keying up the other ones. So I try to key up. I don't get anything back because it has changed over. So I will scoot my radio over to the Benton backup, WRKF394. And you don't hear anything, but you can see right there this signal coming back. It is working. Hitting buttons on my microphone on accident. But anyways, that's how it will work. So we will have information on all of the websites and all that stuff. We'll have different PL tones for each repeater in failover mode, and you'll be able to program those into your radio so that you can just switch over and use it if they ever disconnect from the server and you need to use them in failover mode. And that will allow them to continue operating and be usable even without the big fancy simulcast system control server.